Hey guys, Danielle here. I'm going to teach you all about Module 3, length, area, and volume. We have some triangles, some cylinders, and let's do this. All right, so problem 1. We are given pints, quarts, and gallons, which are part of a doubling system of capacity measure. So we also have jiggers, pints, jacks, jills, a gallon, pill. So we're basically measuring in mouthfuls is the main system we're going to be measuring in. And as you can tell right here, a gill equals 8 mouthfuls. Each mouthful equals 2 mouthful of a picture equals 2 mouthfuls. So there's going to be 8 gills. Let me just write that out. And how do we get that? So 1 gill, trying to find mouthfuls, so 1 gill equals 2 jacks, and 2 jacks equals 4 jiggers, because 1 jack equals 2 jiggers, and then 4 jiggers equals 8 mouthfuls. So that's how I get that. Right? And then for cups, 1 cup equals 16 mouthfuls. And 1 pint equals 32 mouthfuls. Sorry about my handwriting, guys. So basically, if you look at our little thing up here, so a gill, we have 1 gill, we have the cup, and pint. So just to continue on that, if you were to have, say, 1 pint, it would equal 2 cups. And 2 cups equals 4 gills. And those 4 gills equals 8 jacks. Oops. Sorry. Eight jacks. And 8 jacks equals 16 jiggers. And then 16 jiggers equals 32 mouthfuls. So that's how I got the pint. And this was really simple. There could be more complicated problems for this. But this one was really simple just because of the fact that everything equals 2. So you're just multiplying by 2 each time. So you got 1 times 2 equals 2, 2 times 2 equals 4, 4 times 2 equals 8, and so on. All right, so it said, picked a graph to show 1 mouthful, 1 jigger, 1 jack, 1 gill, and 1 gallon poured into an empty pail. Does the pail flow over? Or is it exactly filled, or is there room for more? So how we would do this is add all the amounts of mouthfuls. So right here I've already got a chart showing all the mouthfuls. So we're just going to add all those up. And once you add them all up, you get, well, you don't add this one, sorry. You get 511. And so our pail holds 512 mouthfuls, but once we add up all the measurements between mouthfuls and a gallon, you only get 511. So there's going to be 1 mouthful left over. So you can't, it's not overflowing, but it's not exactly filled. So there's still room for that one more mouthful. All right, so we have to find the area and the perimeter of these triangles. Right up here on the right, top right, I have the formulas. For all of these triangles, perimeter equals sides added of A, B, and C, sides A, B, and C, and area equals half times base times height. So if we look at the top triangle, the first one, our perimeter is going to be side A, which is 48 meters, and then 82.3 side B, and then 69 meters is side C. So we're going to add all these up and we get 199.3 meters, and that is our perimeter. To get area, we have half times the base. Our base is side B, and our height would be the height of the top point of the triangle to the base. So it's going to be 41 meters. So if we do half times 82.3 times 41, we're going to get 1,687.15 meters squared. Now let's work the second one. So we got side A, B, and C. We're going to add them all up, and we're going to get 222 inches. Now, to do area, we can also do, base times height times half. And if we can put it in this form, side A and B, which is base and height, cut in half, which equals 1,642.8 inches squared. Now let's look at the third one. This one's a little tricky, at least it looks like it, but it's really not. So we have sides A, B, and C. 3.1 centimeters is the measurement of this side of the triangle, and that's measurement A. And then we also have this side and this side. So we're going to add all those up, and that's 17.8 centimeters. Now to find area, this is not the height. Our height is actually from the top of the triangle to the base, right here. So it's going to be half times 6.2 times 2.6 is your height right here. And we're going to get 8.06 centimeters squared. So just a rule here, when you're showing your work in class, always make sure to put your units each time. Some teachers count off for it. It's great to show your work. And also it can help you because when you're writing down your measurements, you might notice, hey, instead of centimeters, that's a meter, or instead of inches, that was feet, and you just kind of skipped over it, your math's going to be wrong. So you might have to do a conversion sometimes. Let's go on to the next one. So we have a square with sides of lengths of 10 units. So each side is 10 units. And it's inscribed in a circle and circumscribed around another circle. Which is larger, the area of the region between the circles or the area inside the smaller circle? So how we're going to do that is we're going to find the area of the small circle. And how we do that is just simply to find an area of a circle is pi times radius squared. And our radius, since the square is 10 units, the radius is half of the circle across. So let's just cut in half. And so that's going to be pi times 5 squared. And then that will equal 2.5 pi units squared. And then area of the larger circle is you're just going to do 5 squared plus 5 squared equals radius squared. And then, so that's going to be 25 plus 25. Equals radius squared still. And so now we have 50. So our area is going to turn into 50 pi units squared. So now we're going to do 50. Oh, that's 25, sorry. So 50 minus 25 is going to be 25. So the difference in the circles are the same amount. There's a difference of 25 times pi times units squared. Okay, this one was interesting. So we have a right circle cylinder and a cone shown in the figure below. They both have a base of radius r and a height of 2r, and the sphere has a radius r. So right here I have the little formulas of a volume of a circular cone, a volume of a sphere, and a volume of a right circular cylinder. So basically all you're going to do is find the volumes, and a volume of a circular cone, to find it, we're going to divide all of these divided by the volume of a cone. So volume of a circular cone divided by volume of a cone is obviously going to be 1. Volume of a sphere, here's the formula, divided by volume of a cone. You have the same measurements, but then you have 4/3 and 2/3 down here. So you have double. So it's going to be 2. So then over here you have 2 over 2/3, because your volume of your right circular cylinder is 2 times pi r squared, or cubed, sorry. And so that's going to be equal to 3. So when you do a ratio of volume of a cone to volume of a sphere to volume of a cylinder, you're going to get 1 to 2 to 3. It's not that hard. All right, so we needed to name these two figures and find the surface area. Well, this figure over here, we were given these measurements, and by looking at it, we can count that it has 6 faces, 8 vertices, 12 edges, and it's going to be a trapezoidal prism, because if you look it up, trapezoidal prisms have 6 faces, 8 vertices, and 12 edges. And so to find the surface area, you're simply just going to do 2 times base is pH. So it's going to be now base equals half times A plus B times height equals the trapezoidal base. So if we have half times side A is 26, this is A, and this is B, plus side B is 17, times 12 equals 258 centimeters squared. So in order to find the surface area, now that we know the base, is to do this little formula. So we have 2 times 258 what we got right here, the base, plus 70 times 4. And so this is 2 times base plus perimeter times height. And in order to find the perimeter, I forgot to show you, is you're just simply going to add up the sides 12, 17, 15, and 26 equals 70. And the height is right here, 4 centimeters. So we have 2 times the base times the plus perimeter times height. You're going to get 796 centimeters squared. So that's our surface area. Now if we look at this one, it has 5 faces, 6 vertices, 9 edges. A triangular prism has that many, so that is what this is. And so again, surface area equals 2 times base plus perimeter times height. So first we need to find our base. Base equals half times base times height equals the triangle base, and half times 15 right here times 8, and that is 60 meters squared. Our perimeter is simply 8 plus 7 plus, it's 8 plus 17 plus 15. And so that's going to give you 40 meters. And so now down here, to find surface area, that is 2 times your base, which is 60, plus your perimeter, 40, times your 7 height right here. You're going to get 400 meters squared. And that's your surface area. All right, so now we have to find the surface area and volume of the solid. So I have surface area of a cylinder plus a surface area of a sphere is going to be, because right here you have half a sphere and then you have another half, and then you have a cylinder attached to it. So to find the surface area of the figure, you're going to have surface area of cylinder plus surface area of a sphere. So in order to do that, we have surface area of a cylinder is 2 times pi times r, or radius, times height. So our radius is going to be half of 8, so it's going to be 4. And then times height is 21. And then plus surface area of a sphere, which is 4 times pi times radius squared. We already discovered our radius is 4. So that's going to be 729 feet squared. Now, in order to find the volume, again, we're just going to do volume of a cylinder plus volume of the sphere. So a volume of a cylinder is pi times r squared times height. I'm gonna write that out for y'all. Plus, I'm sorry, I did the volume of the sphere first. Volume of a cylinder, pi times radius squared times height now. So, volume of the sphere is 4/3 times pi. Radius is 4, and it's cubed. Plus pi times 4 squared times 21 for a height. And that's going to equal 1,324 feet cubed. And that's our volume. Now, we were given this figure. We're going to find the surface area and the volume of the solid. Trying to find my pen here. Okay. So we have surface area of a circle plus surface area of a cone plus surface area of a cylinder. Because we're going to use the circle, the cone, and the cylinder. So I have already put the surface area of all these. So now we're just going to put them together. So surface area of the circle plus surface area of a cone plus of the cylinder. So it is pi times radius. Your radius is 2 right here, squared, plus pi times radius again, times the slant, which is 6, plus 2 times pi times radius times height. Here's your height, here's your slant, and here's your radius. So now that we have that, you are going to get 176 meters squared. Now we're going to find the volume. Volume equals this formula up here that I've already got up there for you. And how we're going to do that is, so the pi times the radius squared times the height 1 that we've already had discovered, plus 1/3 times the base, I'm sorry, it's times pi times 2 squared times 5.66 is your height squared. And how do we find that? So height squared is the height of the cone right here, because we know the slant. So it's basically this formula right here, slant of the cone squared minus radius squared. And that's going to be about 5.66 meters. So that's how we found this right here. So once we plug all that in, it's going to be 149 meters cubed is going to be our volume. All right, guys, thank you so much for learning with me. I really enjoyed teaching this. It was some challenging questions, but they seem to be a little bit easier than I thought they would be. So thank y'all.